Hello guys, a very warm welcome to my fourth session of gravitation. Now we have already covered three topics and three parts of this chapter and going to start fourth part. Okay guys, now this is my fourth session of gravitation. Now the we have already covered these topics: universal law of gravitation, universal law of Kepler's law, free fall or acceleration due to gravity. Now let us revise the previous concept. Now the first one we learned that the universal law of gravitation. Now universal law of gravitation said that the force of gravitation is equal to the g, which is constant, in multiplying into product of the two masses divided by the distance square. Now in the second Kepler's law, we learned that there were many scientists who discovered, but the most accurate was discovered by Kepler, who found then the Kepler's law, which was divided into three parts, and the third one, free fall or acceleration due to gravity, in which we learned that free fall is the situation when a ball is thrown, when the ball is falling, and when there is no air rigidity or buoyancy, when only the gravitational force is acting on it. Okay guys, now that is why its other name is acceleration due to gravity. And let's now just practice a few questions on these parts. Now we have already covered three parts, but we haven't practiced questions on these things. Now today we are only going to practice these topics questions, and today there will be no topic understanding, there will be just questions. Now guys, let us move to the questions. Now let us move to our first question. Now our first question is: a ball is dropped from the roof of a building. So first imagine how is the scenery. Now like a ball. Okay, let me draw it. Now a ball is dropped from the roof. So this is the roof. Okay. Now a ball is dropped from here from the roof of a building. Okay, it takes 10 seconds to reach the ground. It means that to reach the ground, okay, imagine that this is the ground. So to reach the ground, the time taken by the ball is 10 seconds. Okay guys, now it says that to find the height of the building. Now guys, I told you that there is air rigidity and also the buoyancy acting on the object when it is not in vacuum. But I also told you that sometimes we ignore these two forces because they are very small forces. So now we can say that it is the free fall because we are ignoring both the forces, and the force that is acting is gravitational force. So now we can say that the acceleration is equal to 10 meter per second square. It is a rough calculation. The accurate calculation is 9.8. Okay guys, now 10 meter per second square, and the height, we have to find the height. So it is dropped from the roof, so we can say that the initial velocity is 0 meter per second square, 0 meter per second. Now what we will do, 10 seconds. So best equation which will suit it is okay, so let us revise the equation that we studied in the previous chapter. So the equation that we studied were v is equal to u plus at. Now guys, okay, we have given that acceleration, okay, initial velocity and time, okay, and now we have to find h. So we have to find such an equation that comprises of all these things. Okay, now in this, if we see final velocity, okay, so now final velocity we don't have. initial velocity we know, acceleration we know, time we know. Okay, so it does not comprise of all these things. Now let us go to the second equation. V square is equal to u square plus 2as. Now in this equation, if we see, okay, v square, okay, v again we have not given, so we can't use this one. And now guys, what is the third equation? The third equation is s is equal to ut plus half at square. Now if we see in this equation, we get all these things. So s is denoted by height only because it's a distance. Now if we put the values, we have given s as, we have given okay, s has given as, okay, s we have to find, height only we have to find. Okay, s we will put like that only. Now u, what is the initial velocity? It's 0, and if it is multiplied by t, it would be also 0, so we don't need to write it. Now the second is given as plus half at square. Now half we have to write. A, now acceleration we have taken as 10 into the t square. So time is given as 10, and if we square it, it comes 100, and the final answer will come 500. So the answer is 500 meters. Okay guys, now let us move on to the next question. Now guys, the next question, yes, now in this question it is written that a ball thrown vertically, okay, vertically up, returns to the thrower after 6 seconds. Now you have to understand this question very deeply, because it is very googly. Now okay, pause my video and try to take 10 minutes, okay, take 10 minutes also, but try to solve it. Okay guys, don't leave it, try to solve it. Now let us imagine the situation. Now he's saying that a ball thrown vertically up, so a person is standing here. Okay guys, a person is standing here and he throws the ball upwards. Okay guys, he throws the ball upwards. Now maybe ball reaches this height and it returns, and it goes up and returns to the person in how many time, in how many seconds? 6 seconds. So can we say that it took 3 seconds to go up and 3 seconds to go down? So we have to just take one path time. So t would be equal to 3 seconds. Okay, now he says that it is thrown up vertically. So I can say that the final velocity is 0. Okay guys, because at reaching the top height, its velocity will be 0. Now it says to find the velocity with which it was thrown up. So he's asking the speed, the initial speed of the object when he throw up. Now for finding the initial initial velocity, we take it as u. Now guys, now since there is no external pressure in this, also we can say free fall and take acceleration as 10 meter per second square. Okay guys, acceleration is equals to 10. Now acceleration is equal to 10 meter per second square. Now from this info, we can use the equation v is equals to u plus at. Now if we put the values, instead of v it will come 0, u you have to find, and acceleration is 10 and time is 3, so 3 into 10 would be 30 seconds. Okay guys, now we have to find u. And guys, one more thing we have to take care. Now now we take downwards as plus and upwards as minus. Now usually we take this only, but you can choose your signs. Like if you want to take up as positive and down as negative, that's also possible. Now since it is now, I will take upwards as negative and downwards as positive. Okay, guys. Now I will take upwards as negative. Now, if I see if upwards is negative, his initial velocity would be minus. So we can say that its initial velocity would be in minus. So we can write it as minus u. Now, if we write it as minus u, if I transform it here, it will become plus. So u would be equal to 30. Okay, guys, u would be equal to 30 meter per second square. Now guys, if you take the acceleration as 9.8 also, that answer would be also correct, because both the things are same. Now, a stone is released from the top of a tower of a height. Okay, guys. Now, a stone is released from the top. Okay, let us make me a tower. Okay, this is the tower, and ball is thrown from here. Now, released on the top of a tower of height. Okay, not thrown, but released. Now, tower of a height. Now, its height is 19.6. Now, guys, it's in points, so I will recommend to take the acceleration to be 9.8, because it will make your calculation easier. Now 19.6 meter is the height. Now we can say that initial velocity is 0 because it is released on the top. Now the height is equal to, means s is equals to 19.6 meters. Now now we can take acceleration is equal to 10 or 9.8. Now I am taking 9.8. If you take 10 also, your answer would be correct, but the calculation will be a little bit difficult. Now height, calculate its velocity just before touching the ground, means we have to find the final velocity. Now if we see here, first we have to find v. Okay, now let us see the first equation. V is equals to u plus at. Now time it is not given, so we cannot use this equation. Let us use another. V square minus u square is equal to 2as. Yes, this equation is perfect. Okay, we will take this equation. Now let us put the values. Okay, now if we put v square, okay, what is v square? V square we have to find. Now what is u square? It's 0. Now what is acceleration? And then we have to multiply 19.6 distance. Okay, now first multiply these two. If we multiply these two, the answer would be also 19.6. Now if I see 19.6 into 19.6 is nothing but 19.6 square, and it is v square. Now we can say that v is equals to root of 19.6 square, which would be 19.6. So the final velocity is equal to 19.6 meter per second. Okay, guys. Now let us practice some more questions. Okay, guys. Now it is written that what do you mean by the gravitational force of attraction between any two objects is always mutual? Now guys, this means first solve yourself and first pause my video and then see the solution, because your thinking might be you are wrong, but your thinking is very important. Think first what your choice says. Okay. Now, this means that both the forces acting on each other are equal and in opposite direction. Okay, guys. Now, the second question is, what is the SI unit of gravitational constant? Now the gravitational constant is this one. Okay, this one. Now, guys, I will not straight away give you the unit digit, but also explain you. Now, like you have already studied this formula, that G is equals, small g is equals to big G, masses of both the objects, product of masses of both the objects divided by d square. Now, guys, in this what we can do, okay, we can put d square here with G. Okay, guys, transformation, and okay, when we put it, it would look like this: G d square is equal to G, big G, into mass of both the objects. Now, what we can do with mass of both the objects, we can put it below it. Okay, guys, masses of both the objects, we can put it below it, and the big G would be equal to small g into d square divided by mass of both the objects. Now, guys, how we can take its value? Okay, just a second. Now, what we will do, our big G's value has come out as small g, which is the constant of gravitation, into yes, now into d square divided by the product of both the masses. Now, first tell me the unit digit of small g. Now, unit digit of small g is meter per second square. Okay, guys, meter per second square. Now, value of okay, now the unit digit of distance. What is the unit digit of distance? Is meter. Okay, meter, and the meter square, because here it is squared, the distance is squared, so we will write it as meter square. Now, divided by the mass of objects. Okay, guys, now we will divide it by mass. Okay, what is the unit digit of mass? Okay, unit digit of mass is kg, but here it is squared, mass is squared, so we have to write kg square. Okay, guys, so the unit digit becomes meter per second square, meter square divided by kg square. Okay, guys, so this is the unit digit of gravitational constant. And guys, one more thing. Okay, the answer of second question, we found it as meter per second square. Okay, meter per second square into this and this. Now, guys, the small g. Okay, now the small g is the gravitation. So this is the gravitational force. So we can also say it as newtons. Okay, guys, Newton meter per square kg divided by kg square. Okay, guys. Now, guys, the accurate unit digit of gravitation is equal to is equal to newtons meter square divided by kg meter per second square. Now, guys, the third question. Okay, the third question says that a stone falling towards earth also attracts the earth with the same force. Is the statement true? So, guys, in this question, guys, this is a very easy question because of the third law of Newton, that it says that every object has an equal and opposite reaction. So the earth would also be attracting the ball, and the stone would also be attracting the earth with the same force. Now, the fourth question, is gravity same as gravitation? Okay, guys, think about it. Is gravity same as gravitation? So, guys, they are a little bit different. like gravitation is the gravity is the amount of gravitation. Okay, so how much how much gravitation makes gravity. Okay, so the earth has gravity, but how much this much gravity, and the force is the gravitation. So gravity is the count and gravitation is the force. Now, guys, let us move on to the next question. And the next question says that on what factors does the value of G depend? Now, guys, the gravitation. Now, the first thing that this G is not the small g one. It's the big G, which is just a constant. Now, the value of constant is always same and never depend on anything. Okay, guys. Now, the next question. Okay, what is the direction of gravitational force of attraction? Now, guys, usually it's downwards, but the direction of gravitational force is along the line. Okay, guys, just a second, like a line along the it's the along the line joining the centers of both the objects. Okay, guys, if you ask direction, okay, these are the 2 points, and the line joining these 2 points, the direction of gravitational force runs along this line. Okay, guys, now the next question is, why is gravitational force between any two ordinary objects very small? So now in this question it asks that why is gravitational force, okay, the gravitational force in any two ordinary objects very small. Okay, now in this question the answer would be, it says that why the force between two objects, like the gravitational force, just the gravitational force is very small. Now, guys, it's only asking why the value is small, so we can directly answer it as the gravitational force between any two ordinary objects is very small because the value of G is very small. Okay, guys, very simple. Now the last, okay, not last, but next question. Now the next question says that gravitational force between two bodies is F. Okay. Now the mass of one body made 2 times, while of another body is made 3 times. How much would be the new gravitational force? Now, what we will do, we will first write the actual original value of gravitational force. Now the actual value of gravitational, okay, just a second, okay, let me erase these 2 circles. Now, guys, now it asks, okay, first we will write the original value. Now what is the original value of G, small g? What is the original value of small g? Now the original value of small g is equal to 9.8. Okay, guys, it's equal to 9.8. Now the formula which I told you, the formula of G is equal to big G into mass of both the objects divided by square of the distance. Okay, now what he says that the mass is of one body is made twice. Okay, is made twice. So now G, okay, the first body, so we can write it as 2m. Okay, now it says that another body is made 3 times, so we can write as, okay, we can write it as 3m. Okay, guys, now we can write it as 3m. Now divided by d square. So now they have not made any other change, just we have to twice the mass of first object and thrice the mass of second object. Now what we will do, now we will multiply these two, 2 and 3, and put it aside, which will become 6. Okay, now we have to cut these with 2. Now if we see, the value is now again same, g into m, first m into second m divided by d square, so we can say it as g. Okay, now it's said that the gravitational force is between two bodies is F, so we can take it G as F. Now the value of F or G becomes 6F, so we can say that what is the, it's asking that how much would be the new gravitation force would be, it would be 6 times. Okay guys, now let us move to the next question. Okay, now these were only the questions, and guys, please do keep practicing such questions, and thank you for watching my video. So today was the practice session of the 3 topics that we have already discussed. I will be soon posting the 4th session, and please do like and subscribe my channel. Thank you.